A very important concept in numeration systems is writing a number in expanded form. That means to write a number using exponents. Look at the example below. 6,543. You've probably seen that written as 6,000 plus 500 plus 40 plus 3. In expanded form, though, we need to use exponents to write the number. So let's look at our 6. The 6 is in the thousands place. Thousands has 3 zeros, so that means it would be 10 to the third power. So you write 6 times 10 to the third. Then your 500 is 5 times 10 to the second. Your 40 is 4 times 10 to the first. And then your units, 3, is 3 times 10 to the 0, because anything to the 0 power is just 1. So now we want to expand 12,345. The first question is, where do we start? We know we have a 1, but what place is that? It's in the 10,000s place. That has 4 zeros, so we're going to start at 10 to the 4th. Then we also need to have a place for each place number after that. So 10 to the 4th, 10 to the 3rd, 10 to the 2nd, 10 to the 1st, and 10 to the 0. Notice I left a little space because we've got to put our actual numbers in there. So we've got 1 in the 10,000s place, 1 times 10 to the 4th, 2 in the thousands place, 3 is in the 100s place, 4 is in the tens place, and 5 is in the units. Notice that every digit is written using 10 to some exponent. Notice that 10 is the base of that exponent, which is why it's called the base 10 system. So thousands are 10 to the third, hundreds 10 to the second, then tens, and then the units place. So let's do another example or two. So we're going to expand 5,067. Again, 5 is in the thousands place, and the thousands is 10 to the third power. So that's thousands. So now we're going to have 10 to the second, 10 to the first, and 10 to the 0. Now let's put back in our numbers. So 5 is in that thousands place. We don't have anything in the hundreds place, so we put in the 0. 6 is in the tens place, and 7 is in the units place. Now what happens if you have a student that gives you this answer? 5 times 10 to the third, 6 times 10 plus 7. Is that correct? Well, it's correct if it's equivalent, so let's compare them. The 5 times 10 to the third is the same. Okay, the time sign looks different, but it's really saying the same thing. Your student left out 0 times 10 to the second, but 0 times anything is nothing, so you can leave that out. 6 times 10 is the same as 6 times 10 to the first, and then 7 is the same as 7 times 10 to the 0, because 10 to the 0 is just 1, and 7 times 1 is just 7. So your student is correct, even though it looks different than, say, your answer key would. So I would like for you to do this problem as your embedded question in this video. Now we're going to go backwards. We're going to rewrite each of these expanded forms into a base 10 number. Now, I've helped you cheat just a little bit because notice we have 10 to the 5th. So that means we need an answer spot for 10 to the 5th. So this is 10 to the 5th, there's 10 to the 4th, then the third, second, first, and 0. So we started with 10 to the 5th, and we now have 6 answer blanks. I'm going to go back through and put these numbers in the correct spot. So the 7 goes in the 10 to the 5th spot. The 4 goes in 10 to the 3rd spot. And the 2 goes in the 10 to the 0 spot. What do we do with all those empty spots? We fill them with zeros. So now let's try the one beneath it. So we've got 5 times 10 to the 6th. So how many answer blanks will we need? we will need 7 answer blanks. Again, I've cheated a little bit. I already put them in there. But that's 10 to the 6th, the 5th, 4th, 3rd, 2nd, all the way down to 10 to the 0. Now I'll go back in and put my numbers in. 5 goes in the 10 to the 6th spot, 2 in the 10 to the 1st spot, and 9 in the unit spot. And then you just go back in and fill in your zeros. So now we've got 5,029,000. So I'd like for you to do this problem and turn it in class.